Bismillahirrahmanirrahim. Assalamu alaikum students. This is your 12th lecture of physics for 10th class. We are going to discuss the geometrical optics, that is your unit number 12. The learning outcome for today's lecture are reflection of light by spherical mirror, image location by spherical mirror formula, sign conventions, refraction of light, laws of refraction, speed of light in a medium, refractive index. Now the first lecture is about refraction of a curved surface, and we are discussed here convex mirror for it. As you know that convex mirrors are those mirrors whose outer curved surface is reflecting. Now we are going to place an object on the principal axis upright. As you can see that the object is represented by a line with an arrowhead. Different light rays are going to be emerged from the head of that object and strikes the mirror. We have three different lines. One is represented by red color, other is represented by the blue one, and third one is represented by the black color. When the red light emerged from the point or head of the object, it will strike the mirror and reflect back. Whereas the second ray, that is the blue one, when this light ray emerges from the head of the object, it strikes the mirror and reflect back by parallel to the principal axis. Whereas the third ray, which is in the black color, when strikes the pole of the mirror, it will reflect back by making certain angle. As we can see that all the reflected rays are diverged rays. They are in different direction. They are not going to be focused on a single point. So what we are going to do, as this is your convex mirror, so it will always form a virtual image. So when we have all these reflected rays, we are going to extend these rays in a dotted line. As you can see that blur lines are going to be these red, blue and black lines are going to be extended in a blur colors in the backward direction. When these rays are going to be extended in the backward direction, all the rays are going to be intersect one another at a single point and make a virtual image. That is how the image is going to be formed by the convex mirrors. Now the reflection of a curved surface by concave mirrors. Procedure is the same. As you know that what actually are the concave mirrors. Concave mirrors are those mirrors whose inner curved surface is reflecting, and we are once again going to place an object on the principal axis. An object is placed in front of the mirror, and this object is represented by a green line with an arrowhead. The light rays are emerged from the head of that object, strikes the mirror and reflect back. As you can see, there are again three lines, three different colors. One is with the red line, second is with the blue line, and third is with the black line. As you can see that when the red line is emerged from the head of the object, it will strike the mirror at a point and it will reflect back by passing through the focus point. Whereas the second line, that is the blue one, it is emerged from the head of the object, passes through the focus point and strikes the mirror, and after reflection it will move parallel to the principal axis. Whereas the third line, which is represented by the black color, when it will strike the mirror at the pole, it will reflect back by making certain angle. All the three rays, red, blue and black, are going to intersect each other at a single point and make a real image over here. Now the image location by the spherical mirror formula. First of all, we are going to discuss the definition. That is, mirror formula is the relationship between object distance p, small p, image distance small q from the mirror and the focal length small f of the mirror. And the mirror formula is going to be write down as 1 by f is equals to 1 by p plus 1 by q. This equation is true for concave and convex mirrors, or you may say you can use this formula in order to make the calculation for concave and convex mirror. However, we are going to use the sign of conventions which should be followed to apply this equation for solving the problems related to the mirrors. Now, a very important thing, that is your sign of convention. You must know what actually are the sign of conventions and when you are going to apply those sign of conventions. For example, as you can see in the table, that object distance p is real when the object is real, it is positive. When the object is virtual, it is negative. The value of p is going to be positive when it is real. Value of p is going to be negative when the object is virtual. Next is your image distance, that is q. Image distance, the value of image is real. The value of image is positive when the image is real, and the value of q is negative when it is virtual. Focal length is positive when you are using the concave mirror, and focal length is negative when you are using convex mirrors. Basically, the sign of conventions are used for your numerical problems. When you are going to solve the numerical problems, you are going to use these sign of conventions. If the examiner says that you are using a concave mirror, then understood that its focal length is positive. And if he is using that it makes a real image, then it means that your image distance is also positive and object is also positive. It entirely depends upon the statement that is given to you. According to the statement, you are going to assign the positive and negative sign to the values of object distance, image distance, or focal length. Now, our next very important article is refraction of light. You have already discussed the refraction for the water waves, and we are going to discuss it now in light waves. Process is same, things are same, properties are same. We are just going to revise it. The process of bending of light as it passes from air into glass and vice versa is called refraction of light. As you can see in the figure, that an incident light ray enters from air into glass, and you can see that the wavelength of the light wave inside the air is greater as compared to the wavelength of the wave inside the glass. As this light ray enters inside the glass, its wavelength decreases. Similarly, its velocity also decreases. When the light waves enter from one medium to another, there is a change in wavelength, there is a change in wave speed, as well as there is a change in direction. You can see all the three things in this figure. Now we are going to discuss refraction of light through a glass slab. This is a very important practical as well, and inshallah you are going to perform it by yourself in the lab. As you can see that the incident ray, which is represented by OI line, traveling from the air, falls on the surface of the glass block. When it falls on the surface of the glass block, the ray of light OI or IO changes its direction and bends towards the normal. It will bend towards the normal, and you can clearly see the difference between the angle formed inside the air and inside the glass. The angle between the incident ray and the normal, which is known as your angle of incident, as you can see that angle of incident is greater as compared to the angle formed inside the glass, that is your angle of refraction. This angle of refraction is lesser as compared to the angle of incidence. So remember this thing, that all the angles, whether those angles are your incident angles or your refracted angles, all the angles formed inside a rare medium is always greater, whereas the angle formed inside the denser medium is always smaller. And you can experience it through the diagram. Now back towards the lecture. Whereas the ray OR inside the glass block shows the refracted ray. The ray IO and OR are called the incident ray and the refracted ray respectively. The angle I made by the incident ray and the normal is called the angle of incident, and the angle R made by the refracted ray with the normal is called the angle of refraction. When the refracted ray leaves the glass, and once again it will enter inside the air, it will bend away from the normal and travels along a path ME, and this ray ME is known as your emergent ray. Now by the above experiment we conclude the laws of refraction. What are the laws of refraction? Number 1, the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. As you can see that the incident ray, when strike the surface, and the normal at the point of incident where the incident ray strikes the surface, and at the same point this incident ray will bend or refracted. So all the three rays lie on the same plane. The ratio of the sine of angle of incidence to the sine of angle of refraction is always equals to a constant, which is represented by small n, and it is known as your refractive index. N is known as your refractive index. N is equals to sine I by sine R, and it is also called your Snell's law. This is a very important law. You are going to use this law in order to calculate the numericals. Now we are going to discuss a very important topic, that is your speed of light in a medium. As we know that there are three types of mediums, solid, liquid and gases, and we know that in solids molecules are closely packed. In liquids they are spaced apart. There are some spaces between liquid molecules, and when we move towards the gases, their molecules are far apart, so they have different densities. The greater the density, as we know that solid has the greater densities, then liquids, and then gases. So according to their densities, the speed of light is different in the different media. For example, the speed of light in air is approximately 3 into 10 raised to power 8 meter per second. However, when the light travels through a medium such as water or a glass, its speed decreases. Why its speed decreases? Because number of collisions are going to be increased. So that is why its speed is going to be decreased. The speed of light in water is approximately 2.3 into 10 raised to power 8 meter per second, while in glass it is approximately 2 into 10 raised to power 8 meter per second. To describe the change in the speed of light in medium, we use the term index of refraction or refractive index. And what is your refractive index? It is n is equals to sine I by sine R. Now our next topic is refractive index. How we are going to define it? The refractive index n of a medium is the ratio of the speed of light c in the vacuum or in the air to the speed of light v in the medium. And the formula is refractive index is equals to speed of light in vacuum divided by speed of light in medium. N is equals to c by v. As you can see that there is a table for different mediums, with their different refractive index. You have to learn this table for completing your MCQ section. Now by the end of my lecture, I'm going to give you some practice questions. For example, define refraction of light, describe the passage of light through parallel side transparent material, which I have already discussed there. Define the following terms used in the refraction: angle of incident, angle of refraction. Both the definitions are explained and given to you. What is meant by the refractive index of a material? Definition is there in the lecture. I have already discussed it. How would you determine the refractive index of a rectangular glass slab? The formula is there. State the laws of refraction of light and show how they may be verified using rectangular glass slab and pins. Again, you are going to use the simple experiment which is given inside this lecture. I hope this lecture is very informative for you and you will enjoy this lecture. Inshallah, we will meet in the next lecture. Until then, Allah Hafiz.